All right, kind of unusual timing, but let's do this. Triangle medium. Given a triangle array, return the minimum path sum from top to bottom. For each step, you may move to an adjacent number of the row below. More formally, if you are index I in the current row, you can move to index I or I plus 1 on the next row. So the minimum path sum from top to bottom. Triangle looks like 2, 3, 4, 6, 5, 7, 4, 1, 8, 3. So the min path here is going to be 2 to 3 to 5 and 1, which is 11. Okay. Here's -10, it's just one triangle, or it's a one element triangle. Okay. To do about this. I think what immediately comes to mind is you could traverse every spot in the triangle and choose the minimum of the two spots that can come before it, or the sum of the smallest path sum of the two spot that comes before it. So for this 5, you can think of the minimum path sum for the 3 or the 4, or up to the 3, up to the 4. I assume that's going to be O of n, where n is the size of the triangle, the number of elements in the triangle. Wonder if there's a faster way than that. It probably should be, right? It's not that big of a triangle, looks like. It's 200 is the length, so therefore it's probably like 200 squared divided by 2, this number of elements, which is not that big. Is there a faster way than that? I feel like there probably should be. So can you do some sort of a heap where you evaluate the lowest current path sum. You evaluate the lowest current path sum. Maybe. And then whenever you pull out the lowest path sum that actually reaches the bottom, then you know that has to be the fastest. So I'm gonna assume that that at worst can evaluate every spot in triangle and consider the min of the two path sum up to that spot to determine best path using that spot. That solution would have time complexity of O of n, where n is the number of elements in the triangle. Question then would be if there is a faster solution. So we're going to try heap, where heap has path sum. only evaluate the lowest pass sum at a time, and once it reaches the bottom, that should be the fastest or the lowest total. Okay. So I have a heap. The heap should start with the first element in the triangle, or the top element. Should be triangle at index or row 0 first element, and should have index, probably the row and column of that. So this would have the value, pass sum, row and column. And that's the tuple. And then so while heap exists, I'll say path sum row column is equal to heap push heap pop from my heap first element, and I'm going to verify that this, so the number, let's say n rows, is the length of the triangle. So if this row is equal to the number of rows, then that means I've reached the bottom, so I can return this path sum. And then I guess this could be a while true, since the heap should never be empty. Alright, so if this is not the bottom, then we're going to add the, if we add, so if I'm at this spot and I add these two to the heap, pass I'm getting to here, pass I'm getting here, it's possible that I can come across a duplication. So for instance, let's say I'm at 5 here, I would add path to 1, path to 8 here, but possible that there was another previous path that went to these things that was shorter, so I don't want to duplicate paths. So I probably want to have a way to verify that I've not already gone to a certain spot in the triangle. So let's say scene is equal to false times, I think I might as well make this n rows. I'm just going to make this a square rather than a triangle 2D array. False times n row for k in range of n rows. Actually, I'm going to just make sure that this is correct. Leetcode. So this is a 4x4 or 4-row triangle, and it's a 4x4. Okay, so it's the right size. False times n rows. Maybe I can just do false times false in range of k plus 1. That might be better. That might be actually triangular than a 2D array, or a rectangular 2D array. Okay. Actually, it's false times. Yeah, that didn't work. False times k plus 1. Okay, yeah. Okay, 1, 2, 3, 4, and just a single 1. Okay. And I probably need to make scene of 0, 0 to be true, I guess. I'm not sure if that's really necessary. I shouldn't be able to traverse to that element, I don't think. Okay, so from this spot at row column, so if it hasn't been traversed to row plus 1 column, so like kind of beneath it, then heap push the path sum to that spot would be equal to the current path sum plus whatever spot that is. So triangle at the row plus 1 column. So heap push path sum 1 row plus 1 column. Heap push has two parameters, the heap and then the tuple that you want to push, or the value you want to push. And then and then I need to make this thing true. If not seen of row plus 1, column plus 1, path sum 2 is path sum plus triangle. Gosh. Heap push, heap, path sum 2, row plus 1, column plus 1. Seen at that spot is true. Okay, I think that might be it. Index out of range. When would this go out of range? Oh, I see. N rows is going to be 1, and the index for that should be 0, so it'd be row plus 1 is equal N rows. Okay. Yeah, so one thing I just realized is going to be that the negatives affect things pretty bigly. The fact that you can actually have a negative value, which means that the path sum is not always strictly increasing. It could be decreasing at certain values. Yeah, so let me think how to handle that. So just because you found the first way to get to this like bottommost row, there might be another way to get to this bottommost row, but the value there is like negative, a huge negative number, so therefore is actually shorter. I think what immediately comes to mind is kind of forcing paths to be strictly increasing in cost. So so finding the minimum value overall of all the values in the triangle, and then readjusting the values in the triangle to such that that is the 0 value, so that becomes 0, and then so for instance, like let's say the 8 here is like -8, or let's make it easier. Let's say this 3 was -3. Then I make this 3 into 0. I make this thing into, so I adjust everything up 3. So I add 3 to this thing, make this a 0. This becomes 11, this becomes 4, this becomes 7. So everything gets adjusted upwards, so that the cost is always going to be non-negative. So therefore, when you are traversing downwards, you are always strictly increasing. And then you make one final adjustment in terms of like your end result from all that would be the path length times your adjustment is like added back into the value of that thing. Add back into the answer. Okay, so I think that's probably how I should want to approach this. Min value is going to be the minimum of my triangle. Let's just make sure this works for a 2D array, I'm not sure. Yeah, that didn't work. So the min value here, I was hoping would be 1. Okay, for every row in triangle, for every value in that row, actually, min row value is going to be the minimum of this row, and min value is equal to the minimum of min value and the min row value. I'll set my min value to initially be just infinity, I guess. Okay, let's see if that works. So here's 1, it's -10, okay. And then I'm going to readjust every value. Just increase every value in triangle by min value. This will ensure that paths are all always strictly increasing. So for every row, actually, is there a way Python increase every element in array by value. Is there an actual function for that? Recommended for new this is definitely not a new list creation using for loop. In place modification. Okay. Okay. For every row in triangle, yeah, for index range of the length of that row, triangle at this, or I guess I can just do row at this index plus equals the min value. Okay, so that should now make it so that, again, once I reach the bottom, it's going to find the shortest thing. And then lastly, it's gonna return past some minus min value times the number of rows. I guess order of operations, this is already correct, but whatever. See the test case. Oh, it's did wrong. Huh. Yes, let me go ahead and print out the triangle. Oh, the min value is negative here. I don't want it. I don't want the negative to make it become more negative. Am I supposed to be subtracting out the min value? So if the min value is a positive, then let's say it's 3. Min value is positive. If min value is negative, then I subtract out the min value. -3 minus -3 is 0. Yeah, this should be subtracted out, right? And then I add back in the min value. This seems a little funky. Okay, guess my mathematical logic is a little faulty here. Oh boy, that's not good. I thought this was a pretty decent speed-wise. I wonder if it was actually faster just to go through every spot. I guess the heat does make it kind of slow. Going through every spot in a 200 by 200 triangle shouldn't be that slow, to be honest. Okay. Maybe a heap is not it. Alright, let's go through it so that it's not I guess this is the non-heap way, so how to do the non-heap way. So for every spot, I need to create the minimum path sum to that spot. Okay. So I guess this would also be infinite times k plus 1 k in range of n rows. And then min path sum of 0, 0 is going to be whatever the initial value is from the triangle. And let's say for every row, let's say row index in range of 1 to the number of rows, and for every column index in range, row index plus 1, so 0, row 0, row 1, I think it's, yeah, row index plus 1. Row index 1, and you go through 1 and 2, 0 and 1. So at this point it should be min path sum of the next row. Actually, I should be iterating over. No, I'm thinking about this wrong. I should be iterating over. Should be row index n rows minus 1, I think. I should be looking at it from the perspective of the initial thing affecting the bottom thing. The top affecting the bottom. And I don't want to use the last row because that's just the final row. Okay. At which point this should be row 0. Yeah, this is still correct. Min path sum. I guess I should just call this row and column rather than row index. And column index. Alright, so min path sum of row plus 1 row plus 1 column okay, this is the spot, so let's say min path sum up to the spot current path sum is going to be min path sum up to this row and column. Min path sum up to the ones below it be the current path sum. Let's say this is a little too two verbose here, path sum. I'll just call this paths. So the current path is paths of this thing. Paths up to the ones below it is, let's say, if paths at row plus 1 column is greater than the current path plus whatever value is there. Plus triangle at row plus 1 column and paths at row plus 1 column is equal to path plus triangle at row plus 1 column. And then do the same thing for the other one below it. If this thing, column plus 1, column plus 1. Okay. Okay, and then I return the smallest thing at the bottommost row. Return the minimum of paths at the bottommost row, which is going to be n row minus 1. Or I guess it's just be negative 1 here. And then with the offset. So I guess I don't really need to do the offset because this thing takes into account every single thing. But let's just do the offset right now. And let's see if how much this compares to the other one. Okay, so this is considerably faster. Okay, again, I think I can remove this min value offset thing. Because this thing actually iterates over every single value. So it doesn't prune by negatives or at all. I don't know how that made it worse. Just random, I guess. The other thing I could possibly do is I could actually save space and not create the paths thing and just iterate over the actual triangle, modifying the triangle. Could you do this in O of n extra space where n is the total number of rows in the triangle? I could do this in O of 1, I think. Actually, I see. You can't do it. You can't do it strictly in O of 1. It's because you have to save the current row. Yeah, you have to save the current row and then like copy over the current row. Okay. So if I wanted to save that space, then I guess I would use I use a dummy row. And I guess it'd be 0 times 0 times n rows. So you store stuff into the dummy row, and then you transfer over the dummy row values into the actual triangle once you're done with that row. Like the dummy row is the next row in the triangle. The dummy row is the next row in the triangle. I wonder if it's better to have the dummy row needs to actually start with like infinity, all infinities rather than all zeros each time. So you could create a new dummy row each time, which seems a little slow. And then modify triangle in place, or copy over the dummy row to the triangle each row. Okay. Let's for each row, let's do dummy next, or dummy row is going to be infinite times I think it should be row plus 1, row plus 2. If you're at row 0, you want 2 elements in your dummy row. Okay, and then for column, so column, yeah, so path to the spot is that, but I don't have paths anymore actually. So path is actually triangle at this spot. And then if the dummy row at column is greater than the path plus triangle at row plus 1 column, and the dummy row at this column is equal to path plus triangle. Now I could just use max or min here, but I think that is slightly slower than just using an if statement, because it doesn't automatically do the assignment if it doesn't need to. This if statement. If dummy row at column plus 1 is greater than path plus triangle at row plus 1, column plus 1, dummy row at column plus 1 is equal to path plus triangle, row plus 1, column plus 1. And then after this, I need a transfer for every column in range row plus 2. Or I could just store the dummy row back into the triangle. I can store the dummy row back into the triangle for the next row. Yes, this doesn't really have O of n extra space at that point, because I'm actually using O of n. This is more like O of n squared extra space. Let me double check that this works. Row plus 1 is the dummy row. And I return the minimum of triangle at -1. Yeah, this is of n squared extra space because you're creating a new dummy row each time. So if you didn't want to create a new dummy row each time, then it'd be something like, it'd be just slower, I think, because you have to reset it to infinity. What is going on here? Why doesn't this scoot up? Yeah, okay, I'm done. This is way too in the weeds for me. Okay. Well, turns out you can use heap, but it's too slow. It's slower than just using a method that iterates over all elements of the triangle and does the simpler min path logic to that spot. Alright, so I don't know, summary. This is basically iterate over every spot in triangle, calculate the min path, calculate the min path to each adjacent cell below it, min of the current path and whatever is already there. There was a slightly better way. Actually, for each spot in the triangle, maybe I should have just done something like each column in range of row. No, yeah, in range of row. Then I can just do something like combine these two, get this, combine these two, get this, combine these two, get this. So this is index 0 combines get index 1. So a dummy row at column plus 1 is equal to the min of triangle at this row and at this row and column triangle this row and column +1 plus whatever's there. Whatever's there is row +1, column +1. I think that would work. And then there's the two special n ones, which is dummy row at column 0 is triangle at 0, this row column 0 plus triangle at row +1, 0. There's nothing to compare there. Dummy row at the very end, triangle at the last, plus row +1 at the very last. I should probably just comment this. I think that works. Probably slightly faster. Yeah. Yeah. This is whatever, man. Alright, time complexity, this is gonna be O of k, where k is the number of elements in the triangle, which is technically k is probably going to be n squared, where n is the number of rows, like the number of elements is on the order of n squared divided by 2. As it needs to iterate over every spot in the triangle. The heap method, I think, is faster in theory, as it should only explore paths that are shortest, but still has a worst case of n squared. Yeah, n squared. Since it might need to still check pretty much everything before the last row before it goes to the last row. Space complexity, this can be O of, well, I think my solution was O of k, since dummy rows ended up using space equal to the size of the triangle. If it's possible to have it be O of n if reusing the same dummy row. I created new dummy rows for each row, but if you want to reuse it, you have to reset everything to infinity, I think, at the start, and then do a copy values of the values in that row back into the triangle at the end. So I think it's slower, because I think taking more memory, allocating that memory is probably faster than trying to do a bunch of copies and pastes.